Let's start using that idea of special triangles and take it one step further. Read the question. You've got two wires that are connected to a tower. Usually when they're connected to a tower, you call them guy wires. At the same point on the tower, so they're connected to that point, let's say right up there. Okay, now wire 1 makes an angle of 45 degrees. So let's draw it and try to draw these accurately so that you can see them. There's the 45 degrees that makes an angle with the ground. Okay, now the other one says wire 2 makes an angle of 30 degrees. Well, angle of 30 degrees is going to be a little bit more further out. It's going to look something like that. Okay, soon as you see that, you should understand one thing. The 45, right? Instantly think the 45-45 triangle. Instantly. This one's 30, so instantly start thinking, that's 30. Okay, we'll do the 30, 60, 90 triangle. See what I mean? Okay, this question A says just draw the diagram. Well, guess what? I just did. But now B says if the point of the wires connect to the tower at 35 meters, guess what? Your tower is 35 meters tall, right? And then it says determine the length of each wire. Okay, that's what you're after. Determine the length of each wire right here to the nearest tenth of a meter. Now, we can do this the old way, the grade 10 trig way. And notice something that it says right here in the question. It says to the nearest tenth of a meter. Well, that really sucks because the reason why is because you're now dealing with a rounded number. You're not dealing with an exact number anymore. So this is going to be some sort of rounded number that you're going to end up rounding and having to the nearest tenth of a meter. How accurate is that? Sometimes not the greatest. Okay, so how do we do this? Yep, SOHCAHTOA, there it is. What I'm going to do is I'm going to draw our first triangle, which is this guy right here. And I'm going to use SOHCAHTOA to find the length of this wire. That's what we're after. So if I draw it over here, just happen to have it right here, this is what I'm looking for. Making the diagram a little bit bigger, that's the side I'm looking for. Remember, this is a 35 meter high tower, perfect there. That's 45 degrees. Using your wonderful Math 10 skills, you know and I know there's the 90 degree, that's going after the hypotenuse, so you're actually trying to find the hypotenuse. Putting the eyeballs on that one, looking over here, that of course is the opposite then. Okay, so you're dealing with opposite over the hypotenuse. So opposite over hypotenuse, that is sine. So we'll go sine of 45 degrees, opposite, which is 35, over the hypotenuse, which is the length of the wire. We'll call it W. Doing a little bit of wonderful math here. 1 times 35 divided by sine 45 is what it's going to be. So W is 35 divided by sine 45. Let's boot up our calculator and see what we get for a number here. So 35 divided by sine 45, let's do it. 35 divided by sine 45, boom, gives you an answer of 49.49. So surprisingly enough, that's going to be 49.5 because it says in the question to the nearest tenth. So we've got 49.5 here. 49.5, and I think that's meters. Yup, it's meters. 49.5 meters, that's the length of that one. Let's go out and do the other one now. Think about it. We have another triangle over here at 30 degrees, 35 high, okay? Here's my nice triangle. There's my 30 degrees. There's 35. Again, I'm trying to find the hypotenuse. You're doing that quickly. Boom, boom. Look at that. That's opposite. Okay, OPP. That's the hypotenuse. So again, we're going to use sine. And sine in this case is going to be sine of 30 degrees now because that's what this guy is right here, 30 degrees. Is opposite 35 over hypotenuse, which works out to be basically the same math here as before. We're going to take the hypotenuse, we're going to call that W2 for the second guy wire, and it's going to be basically 35 divided by sine 30, and that's going to be our answer there. And I'm not going to go through too much of the grade 10 math because I think you know it. Sine 30, there it goes, bang. That gives me a distance of exactly 70. But remember what the question said. The question says, what is the length of the wire to the nearest tenth? So that would be 70.0 meters. Aha, very important. Now, that's very, very grade 10. And like I said here, thinking about this one, we're going to have a decimal place, which is a rounded number. That sucks. So let's go and now let's figure this out the way a grade 11 trig question would work. All right, first things first, you know a couple things. One of the things that you know is this angle is 90, that's 45 right here and 45, making these two sides the same. So if you remember, that's 1, 1, root 2 on your standard triangle. Now, what I do is I draw the exact same triangle again, but what I do is I put the numbers in. The numbers being, in this case, right? Think about it. We don't know this distance right here, but we do know that this is 35 meters. Well, guess what? If that's 35, so is this. What you're trying to find is this. That's what you're after. You're finding the length. Well, now, surprisingly enough, this is a really easy ratio question because all you have to do is say, okay, 1 is compared to 35. So 1 is compared to 35 as root 2 is compared to x. Root 2 is compared to x. That's one of those proportion questions that you learned all the way back in about grade 8 or so. And all you have to do now, real simply, is cross multiply. 35 times root 2, there's the other cross multiply, so 1 times x is just plain old x. 35 times root 2 would be 35 root 2 meters. And this would be an exact number. Why? Because look, that's not rounded. That's exactly root 2. Now, I know what you're probably thinking. Well, how's 35 root 2 the same as what our answer was up here, which our answer was 49.49 this, right? Well, try it. 35 times the second square root of 2, hit enter, watch this, it's exactly the same number. This number is 49.49, this number is 49.49, that is the exact version of that number. Isn't that wild? Awesome, love it. Let's see if it works again on the other one. Okay, you remember this one? We had a 30 degree here, we had a 60 degree here. Okay, now the problem is this is a little bit different than what we're used to because there's the 35 meters here. We want to find this guy. But remember what we used before. We used a special triangle and I always said that the 60 sinks to the bottom and the 30 degrees floats to the top. Well, let's see how that works then. How are we going to do it for this particular one? Simple. Draw out that same triangle that you're used to. There's your 60 degrees, sinks to the bottom. There's your 30 degrees that flows to the top. There's your right angle. Count 1, 2, root 3. You know that's what it is. Okay, how does it relate to the one that we have over here and how do we solve this thing? Well, it's actually quite easy. All you basically have to do is remember, this is the 90-degree angle, this is the 60. There's the 90-degree angle, there's the 60. So that's the side that relates to this guy right there. That's it. That's how it works. Look at the commonality between them. So you can say that 1 then is the same as 35. That's how it relates to it. Okay? Then look at the other part being, there's the 2, that's the hypotenuse, and that's what you're after here. You're after the hypotenuse. 2 is to what you're trying to find, wire 2. So 2 is to wire 2. Look at that. All you have to do is cross multiply now. 2 times 35. Wire 2 then, of course, is 70.0 meters. And of course, this is an exact length because you're using special triangles. And it's pretty easy to do that way. If you want to see this again, my suggestion is to back up the podcast at this point and look at it again and see how it works because that's really, really cool. Now, last question, and I'll be real quick about this. I love this question because so many people are just really, really silly when it comes to this question. It says, which one is longer? And people look at this and go, well, you got 70 here, and the other one, if you remember, was 35 root 2 meters. Well, I don't know which one is longer. Duh. Why don't you just draw it again, and you'll see. Remember, this was a tower, this was the ground. And if you actually put them on the same sides, you're going to understand where we're coming from. Look. There's 45. Why? Because these lengths are the same. That's the 45. In order for it to be 30 degrees, you're starting here. 30 degrees would be way out here. Look at this. Because it's got further to travel to get to the top. It's not as steep. So of course this wire 2 is going to be longer. It makes absolute sense. But you wouldn't believe how many people I fool on this question. So There it is. Take a look at it. Sorry for a long podcast, but there you got it.